good evening. How are you all doing all over South Africa or everywhere you are watching us from? I hope you're all good. It's been quite some time without being engaging together, but here we are again preparing for our trial exams. So before we go and jump in to prepare for our trial exams, let's just do our memos for the papers which we wrote in June. I hope you guys, you all passed, and I hope you are now ready for us to commence with the preparation for the trial exam. Please don't forget to apply for the different institutions which you want to go to. I think other universities are starting to close now. Please make it a point that you apply, so that next year you can be in the institution which you want to. Without wasting much time, let's get down to the business of the day. If it's your first time, you know what to do. Please subscribe, share and comment and just like and also interact with us during this live session. There's a comment section which is active right now on this YouTube, and also you can text us on WhatsApp. There is a link in the description of this video. Just tap that link, then after that you can be able to interact with us even on our WhatsApp group. Without wasting much time, let's dive into what we want to do today. So today, from what people were asking in the group, wanted us to look at the functions and financial maths as well as calculus. So that's what we're about to do. So as you can see, this is your June 2023 paper 1, which you wrote a month ago. So let's do the revision of that, then we can see if we can be able to finalize everything. Let's engage, guys, on the comment section. I'll always be checking the comment section so that you can be able to have nice time during this live stream. Now let's get down. Now this is your paper. As you can see, it was written this year. This is the EC paper, Eastern Cape. So let's see, what do we have here? Now this was 150. It was not really hard. It was quite great. Of course, always solving for X, 24 marks, 25 to 24 marks. It's always like that. This is your number patterns. This is so straightforward. So now we're gonna start on question number 4, where we'll be looking at functions. So just a quick recap on functions. What is important is to understand that from grade 8 you were taught about the different types of function which you'll be able to learn. So I think grade 8 you're only introduced to straight line functions, where we are looking at y is equal to mx plus c, or y minus y1 equal to m x minus x1. Then we were also introduced now in grade 11. On grade 10 we're introduced to what we call a parabolic function, which is always in a standard form or in a x-intercept format or in a turning point format, which is y equal to a x squared plus bx plus c. Then also when it's in the turning point formula, it's a open bracket x minus p all squared plus q. Then we also have the x-intercept formula under the parabola, where we say y is equal to a open bracket x minus x1 x minus x2. Then after that you should be able to calculate our turning point. Of course, x is equal to negative b over 2a. So those are the things which you must remember about a parabolic function. Now we have this beautiful third function which we call the hyperbolic function, where we have what we call the vertical and the horizontal asymptote, which you find on the value of p and the value of q. And when we are plotting our function, we must make it a point that our graphs where we are plotting, they don't touch the asymptotes, because they are so crucial and so important. Then we are also able to determine the domain, of course, the range of a function, looking at the vertical and the horizontal asymptote which we have as well. Then also looking at also the hyperbolic function, must be able to determine the axis of symmetry, then just to be able to do some few analysis on the graph. Then the fourth one, we're introduced to what we call an exponential function, where we are looking at the perspective that our function is y equal to ax to ab to the power x plus p plus q, where q is the horizontal asymptote. So on the horizontal asymptote, our graph cannot touch the horizontal asymptote. So the exponential function only have the horizontal asymptote. Then we looked at this something which is so important, which we are introduced to in grade 12, what we call the inverse function. So there are only 3 steps to an inverse function. We always know that. What do we do first? You swap x and y, then after that you solve for y, then boom, you're done, and you have your function which you want to play around with. So now let's solve this question. Functions on maths, and if you want more clarity on functions like basic and step by step, please also on the video description here on Yebo Tutor, we have the perfect video for you from grade 11, grade 8. we come up until we reach to grade 12. So now let's just go and dive straight to the questions which we want to look into. Great. Now, question number 4, the diagram below shows the graphs of f of x equal to 5 over x plus p plus q and g of x, which is 5x squared plus 10x plus 3. The moment you see these two equations, you can generally already see that, oh, f of x is our hyperbolic function, then g of x is our exponential, so it's our parabolic function. The two graphs intersect at s, which means the two graphs, they are having the same coordinates. The x and the y coordinates of the two graphs are the same at point S, and we have our y-intercept. So y-intercept of the both graphs is also noted there. So we always know that the y-intercept, which means the x value on that specific point, is equal to 0. Then of course R is the x-intercept of f. Oh great. So if that's the x-intercept, which means at the x-intercept our y is equal to 0, then the asymptote of f cuts at t. Where is t? Oh, there is t. And we can actually see that that's the turning point of G as well. So those asymptotes are so important. That's the sort of like the point of intersection of the asymptote, the vertical as well as the horizontal. And the beautiful thing, the x value there is also going to be the same as the x value of the this point of intersection. But it's just a general analysis before we answer the question. Now let's look at the question. Write down the coordinates of S. Oh my word. What is the coordinates of S? We can see that that's where the two graphs are intersecting, and actually we can see that at S it's the y-intercept of both graphs, which means the x value there is already 0. So for that fact, our life is already easy. Why is it easy? Because now we are just solving for the y value. Okay, now let's get down to it. Let's get down and let's just not talk. Great, let's go. Question number 4. So we can see that S is a point on the y-axis, so which means 0 is to y. Now we should calculate now the y value so that we can be able to have the coordinates of S which they have asked. So of course we can just say substitute S 0 is to y, and we substitute that in g of x since we are given the equation of g of x. Okay, so therefore our y will be equal to 5 0 squared. Let's maximize that a little bit so that we see our g of x. So that's 5x squared plus 10x, which is 10 times 0 plus 3. Then after that we have y equal to what? Y is equal to 3. So then therefore our s is 0 is to 3. So that's the coordinates which we are looking at when we are solving that problem. So that one was not hard, that was straightforward. Now let's proceed to the next question which we have here. Just give me 2 minutes. I'll be back just now. I apologize for that small glitch which I was having on my side, but let's proceed. Now we know the value of x of s. Now let's go to the next question which we have here. Now determine the coordinates of t. What is t there? t, we can actually see that that's the x-intercept of the turning point. So let's actually just determine the turning point of the graph. Okay, so our graph of g of x, that's g of x is equal to 5x squared plus 10x plus 3. Okay, then now we want to determine the coordinates of t. So how do we do that? That's already easy, because t, we can actually see that that's the turning point of the function of g of x. So let's just determine the turning point. So we know that, of course, this is our 4.2.1. we know that x is equal to negative b over 2a. This is a, this is b, and this is c. So this will be equal to negative 10 over 2 times 5. Then we get our x value to be negative 1. Then after we have our x value to be negative 1, now we should calculate the value of y. Then y will be equal to what? 5 times negative 1 squared plus 10 times negative 1 plus 3, which is equal to what? Then we use our Casio calculator all over there. So 5 times negative 1 squared plus 10 times negative 1 plus 3, then I'm getting my answer to be negative 2. So the y value is negative 2. So then therefore the coordinates of t will be negative 1 is to negative 2. Then just like that, we are happy, and now we have the coordinates of t. So you can see that functions are so easy and straightforward. Now, what is the values of p and q? So we can actually see that now they want the value of p. So this is actually easy, guys. So we can actually see that our value of p there, since it's positive, and therefore this is 4.2.2. So p will be equal to 1 and y will be equal to negative 2. We are taking it from here. Okay, so we can see that if x plus p is equal to negative 1, this is the x value here, then definitely you can be able to calculate p and say x plus p is equal to that. So that's how we'll be able to see that part there. Then of course the y value, we'll find it from the turning point value, which is negative 1 is negative 2. So that's where these two values are coming from. This is our q. Now next question. Don't hesitate to ask a question, please. The length of OR. Where is OR? Okay, OR. So how do we calculate the length of OR? So in other words, they want to know the value of, or the coordinates of R, but they're asking in an indirect way. Okay, so how do you calculate the coordinates of R? Of course, we know already 4.2.3. We know already that R is an x-intercept, so it's going to be x is to 0. So when we substitute it into our function of f of x, then therefore now we have 5 over x plus 1 minus 2 is equal to 0. This is the value of y, which is 0 here, as you can see. Then now we can solve for x. Then that will be what? 5 is equal to 2 times x plus 1, because we transpose this 2 and it's positive. Then we cross multiply there. Then we have that. Then 5 is equal to 2x plus 2. Then that will be 3 equal to 2x. Then divide by 2, then of course that will be x is equal to 3 over 2. Then we are happy there. So definitely the distance they want, of course the coordinates of r will be 3 over 2 is to 0. So the distance will be equal to the length of OR will be equal to 3 over 2. Why is it 3 over 2? Of course, guys, this is straightforward, because you can see that from the center to point R, it's 0 here, and here it's 3 over 2. So it's going to be 3 over 2 minus 0. So that's why we're saying the distance is 3 over 2. So they just wanted to ask for the x-intercept indirectly, just to confuse you guys. So that's how everything goes. They just wanted to confuse you guys. But nonetheless, let's proceed to the next question. Proceed to the next question. The range of G is our parabolic function. So we know the range. We look at the y value of the turning point. So the range will just be easy. we can just say this is 4.2.4. We know that it's y element of real numbers, of course, where y should be greater or equal to -2. So we look at the coordinate of the turning point of the function. Then after that we look, is it up or is it smiling, or it's not smiling, it's angry. So it's either it's happy face or not happy face. So if it's a happy face, you can see that it's above, looking forward, coming from this point, going to infinity. So someone can actually write it as y is the element of real numbers where y is coming from what? From -2 and is going to infinity. As you can see, it's gonna go to positive infinity numbers. That's why we just say y is the element of real numbers where y is greater or equal to -2. Then we are happy about that question. Now let's proceed to the next one so that you can be more happier. Determine the equation of the tangent at g of g at s. Okay, g at x. Now we should apply our calculus now so that you can be able to solve that question fast. Okay, so we are given, this is now 4.3.1. we are given g of x, which is equal to 5x squared plus where is it, we're given 5x squared plus 10x plus 3. So we know that according to calculus, we can now be able to determine the gradient of that line. How do we do that? We start by finding the first derivative. So g prime of x will be equal to 10x plus 10. Okay, then after that you can now substitute the x value at s where they want us to look at. So that's the specific point which they want us to look at, and at s we know that the x value is 0, so that will be 10 times 0 plus 10. Then therefore our gradient will be equal to g prime of 0 is equal to 10. Now we can now determine the equation of that line. Of course, we already know that y minus y1 is equal to x minus x1. So what is y1 and x1? That's the coordinates which we are just substituting there, because now we already know the coordinates which we are looking at s. So these are the coordinates of s, so these are the coordinates which we are substituting in that question. So substituting those equation, that it will be minus 3 equal to 10x minus 0. So that will be y equal to 10x plus 3. So this will be our equation of the line. Then we are happy. Now let's proceed. Now the axis of symmetry of f with positive gradient. So we still remember that f of x is equal to 5 over x plus 1 minus 2. So when they say axis of symmetry, which means we are looking at our denominator going, so we are looking at this segment here. Okay, so the moment they ask for the axis of symmetry, that's why they are looking for. So therefore we have y, since they say positive gradient, so we just have x plus 1 minus 2, which is the same as y equal to x plus 1 minus 2. Then y is equal to x minus 1. So that will be our answer there, and that will be our axis of symmetry. Now looking at the last question, 4.4 there. 4.4, for which values of x will g prime of x times this function less or equal to 0? G prime will be our gradient of the line, and times f of x be less or equal to 0. So where is these two functions negative, so that the where is these two functions, another one is negative and another one is positive, so that we can have a number less or equal to 0. So that's how you just analyze it. The way I'm analyzing for you, that's the same way you'll be able to analyze it for yourself as well. So definitely that will be where x is greater or equal to 3 over 2. After the value of r, that's when these two functions will definitely be less or equal to 0, as you saw from the function which we have there. Now let's proceed to question number 5. I'm so happy. We are moving and we are cruising so perfectly. If you have any question, don't forget to drop your question on the comment section, okay, so that we can listen to what you have and we can interact together. Now let's look at question 5. Question number 5. Okay, given h of x is equal to a to the power x, where a is greater than 0 and a is not equal to 1, and we are given b negative 1 is to 1 over 2, which is a point which is also lying on edge of x. So what will be the answer there? What will be the answer there? it's so important for us to be able to realize the answer in that question. So now let's just delve there straightforward. Now determine the value of a. Boring. How can they not know the value of a? So we are given h of x, which is equal to solve this problem. So how can we solve this problem now? How can we solve this problem? Okay, here we are. So let's substitute this into this. So that will be 1 over 2 is equal to a to the power negative 1. Okay, then of course this is the same as 1 over 2 equal to 1 over a. So that will be a is equal to 2. So our a value here in this question will be equal to 2. Just like that, we are happy and the answer is correct. Now I write down the equation of h inverse in the form of y. So now, in other words, they want the inverse function. So how can we determine the inverse function? We know that y is equal to 2 to the x. So the first thing, we swap x and y so that we can have our inverse function. Then we have to solve for y. So this will be log 2x equal to y. So then therefore our inverse function will be equal to log x base 2. Okay, then after that we are happy for that. Now they are saying sketch the graphs of h and h inverse on the same axis, clearly show all intercepts with axis. Of course, we expected them to ask that question. That's already an easy question for us because we already know all the x-intercept. You also know the point B, which is all located on the function. So this will be our function here. So the first one is the h of x function. Of course, it will pass through point 1, so it's going to be something like this. So this is our h of x. Then of course it has been reflected along the line of y equal to x. Then now we have our inverse function also at point 1 here. There we go. So this will be our function. Then we are given point negative 1. Negative 1 is somewhere here, is to half, so it's somewhere here. So yeah, somewhere here. Let's just say this is where our half is. So this will be maybe point B here. Negative 1 is to 1 over 2. Then yeah, we are done. This is our h inverse function. Then we get full marks for being able to draw that specific graph which we have there. Any questions, guys? Anyone with any question? Okay, seems like we are all happy and no one have any question. So now let's proceed. Determine the equation of asymptote. Okay, before that's far. So now write down the domain of h inverse. It's easy. We can see this is h inverse. The domain will be x must be greater or than 0. X must be the element of the real numbers where x must be greater than 0, because we can see that this function is always greater than 0 here. And so this is the asymptote here of the inverse function. This will be at the asymptote of the inverse function. So x must be greater than that value there. You can see this is the asymptote here for this inverse function. So x must be greater than that value. Then now, so you just say x is the element of real numbers where x must be greater than 0. Then now they're asking the second question. Determine the value of x for which this is greater than 1. So this is easy, guys. You either solve it or you can just write the correct answer. Okay, when you solve this, it's gonna be what? the inverse function was log of log 2x, so now it must be greater than 1, so x will be greater than 2 to the power 1, so x must be greater than 2. Or you can just analyze it from the graph that, okay, where is this function which they are saying greater than 1? It's greater than 1 when x is equal to, which is when x is greater than 2. So that's where you can see that, oh, okay, then that's that, just like that. So these functions are so easy and straightforward, and they are so super nice, guys. Okay, now let's look at that question. If it is given that f of x is equal to 1 over 2 to the power x minus 1, describe the transformation from h to t. Oh my word. So we can see that the original was h of x, so it has been shifted 1 unit downwards, of course, because it is a negative on that value. Then now it's 1 over 2. Initially it was 2, so also we can see that it has been reflected about the y-axis. Okay, so we can just write it as this, okay, or maybe you can just explain in terms of writing. So f of x is initially 1 over 2, so is it 2 over, yeah, t of x is initially 1 over 2 to the power of x minus 1. Okay, so this has been derived from h by saying 2 to the power negative x, okay, minus 1. So this means that the function, sorry, let's show this part. So this means that the function has been reflected about the y-axis because of this negative on the x alone. So it shows that it has been reflected along the y-axis and shifted 1 unit down. Okay, then you get your 2 marks there. Now determine the equation of the asymptote of g. Of course, this is the asymptote, y is equal to negative 1, because we say that the exponential function only has one. It only has one horizontal function. Now we are done with that question. Now we want to look at financial maths, then we also look at our calculus. Let's look at calculus first before we look at financial maths, okay, because financial maths can take some time because we must look at our annuities differently. Do we have anyone with any question? Is there anyone with any question? Talk to us if you have any question. Talk to us if you have any question, please. Talk to us if you have any question. Talk to us if you have any question. Okay, seems like everyone is happy. So since everyone is happy, let's proceed. Let's start with our calculus. Calculus is nice, more than functions. Okay, so now let's look at our calculus and just try to see if we can be able to solve our calculus as quick as possible. Right now, calculus, we are here for you. Question number 7. Question 7. Let's go. Determine f prime of x from the first principles. Yo. So when they say from the first principles, which means we must derive it from the initial stage without just using the derivative rules, okay, the power rule. So let's do it fast, quick, and we are out there. So this is our function f of x, so we should know f of x plus h, so that would be 5 minus 2 x plus h all squared. So we expand that, that would be 5 minus 2 x squared plus 2hx plus h squared, then that would be equal to 5 minus 2x squared minus 4hx minus 2h squared. Okay, so this will be our fx plus h. Then since they said from the first principles, then therefore we must have f prime of x, which is equal to the limit as h approach 0 of f of x plus h minus f of x, or divided by h. Now let's substitute this. So that will be the limit as h approach 0 of 5 minus 2x squared minus 4hx minus 2h squared minus what was of f of x initially, it was 5 minus 2x, okay, squared. Then we divide everything by h. Of course, we can remove this bracket there, here. Then when we remove the brackets here, that will be positive here, okay. Then after that, this and this will cancel, this and this will also cancel, because they are giving us 0, they are like terms. Then the limit as h approach 0 will be negative 4 hx minus 2h squared divided by h. Then we look for a common factor on the numerator, which is h. Then that will be negative 4x minus 2h. Then of course you divide by h. Then h and h cancel out. Then we have 0 there. Then now we have the limit as h approach 0, which will be negative 4x minus 2h. Then now we can substitute our 0 there. Then that will be negative 4x minus 2 times 0. Then we have negative 4x as our f prime of x. Then we are done, just like that, just like that, just like that. We are happy, we are happy, just like that. So let's always be happy, guys, because of that. Let's look at 7.2. Let's look at 7.2.1. Now determine f prime of f if we are given that f of x is that. So now we are now using the power rule, okay. So f of x is equal to 2x to the power 5 minus 7 square root of x plus 1 over x. So this is straightforward, guys, okay. So we know the power rule. For instance, when you are given y is equal to 10x to the power, let's just say x to the power 10, okay. So when we use the power rule, it's always 10 times 1, that will be 10. Then now we subtract minus 1 there, so that will be 9 there. So that's how you find the derivative of this function. So now we are applying the same methodology to be able to solve these few questions. So now f of x will be 2x to the power 5 minus 7x to the power 1 over 2. Now we can convert that square root of x, then we write it in the form of a fraction, okay, and have an exponent there. Then plus, of course, 1 over x is the same as x to the power negative 1. Then f prime of x now is equal to 10x to the power 4 minus 1 over 2 times 7. Oh my word. 1 over 2 times 7, that's 7 over 2 x. Then 1 over 2 minus 1, that will be negative 1 over 2 minus x minus 2. So this is our f derivative there. So you can write it in the positive way, which will be equal to what? 10x to the power 4 minus 7 over 2 root of x minus 1 over x squared. Then yes, here we are, and we are done. So I said it before that calculus is more fun and more easier than the one which we were looking at before. Okay, now let's proceed to 7.2.2. You see, this is just 11 free marks. Okay, so now we are on 7.2.2. we are given d over dx of 2x squared minus x minus 6 over 2x plus 3. Then they say we should do this, we should derive this. This is easy, guys, because now we can see that we can solve this according to your level, guys. So you can solve this with one way, that you should find the factors in the numerator and solve that trinomial first. Okay, so by solving that trinomial, we have, of course, d over dx, which is 2x plus 3. Then another one will be what? X minus 2. So you can use your calculator to find all the factors. So me, I'm able to see it. So you guys, please, I urge you to use your calculator to find the factors, or just use the bars, which is the quadratic formula, to find the factors properly. So definitely this and this will cancel. Then now we have d over dx of x minus 2. So we can now derive this, and we can actually see that the answer there will be equal to 1. That will be our derivative, because we know that x will be 1 times 1 is 1, then x1 minus 1 is equal to 0, then anything to the power of 0 is equal to 1. Then we are done with question 7. Just like that, we did calculus in less than 5 minutes. Wow, that's amazing. Now let's look at question number 8, okay, which has 20 marks. Let's try to do it fast as well. So now we are on question number 8. Question number 8. Given f of x is equal to x cubed minus 5x squared minus 8x plus 12, and we are also given g of x, which is equal to ax plus p plus q, sorry. Then we are also given that a, b, and c are the points of intersection of f and g. Oh my word. So these functions intercept at 3 points. We know that this is a cubic function. So a cubic function has 3x intercept, it has 2 turning points, it has a point of inflection. So now let's solve this problem as quick as we can. So the first question says, determine the coordinates of the turning point of f. So we know that at the turning point, we should first determine the first derivative first, so that you can be able to see the coordinates, or to be able to calculate the coordinates of the turning point. So now let's do that. Maths is so nice. Maths is so easy. This paper is so nice, guys. I hope you can see that as well. So now we are on question 8.1. So f of x is equal to x cubed minus 5x squared minus 8x plus 12. Then f prime of x will be equal to what? 3 times 1, that's 3x. 3 minus 1, that's 3x squared, minus 2 times that's negative 10x, then minus 8. Then just write this nice English and say that at turning point, f prime of x should always be equal to 0. Okay, always at turning point. These are the stationary points which we are talking about. So if that is equal to 0, then therefore we have 3x squared minus 10x minus 8 is equal to 0. Okay, great. Now we can now solve for these values. So I advise that you use your cashier calculator again to find the factors using the quadratic formula. But if you're able to just solve it fast as I can, so I also advise that you can do that. Of course, that will be what? 3x. That will be x. That will be 8 there. So then definitely we have negative 4. Then of course 10. So let's have negative 2 also, positive 2 there. So that will be equal to 0. Then therefore our x will be equal to 2 over 3, negative 2 over 3, or x is equal to 4. But we are not done. These are just x values. They say that write down the coordinates of the turning point of f. So how do you find the y values now? We substitute x equal to negative 2 over 3 and x equal to 4, so that we can get the 2 coordinates of turning point. So if we substitute negative 2 over 3 there, then we'll be able to see that, okay, let's substitute. Then we substitute there. That would be negative 2 over 3 cubed. Then we use our calculator there. Then I am getting the y value here, which is equal to 400 over 27. Then for here, I'm getting my y value to be negative 36. Okay, so these are the 2 turning point coordinates. So we can actually write it as negative 2 over 3 is to 400 over 27. Then also we have another turning point at 4 is to negative 36. Okay, then you have your 4 marks. So 1 mark for finding these 2 coordinates, and also those 2 marks there. Then after that, you live happily ever after. Calculus is so nice and so important. Enjoy it with me, guys. It's so nice. It's super nice. Now let's proceed to the next question. Determine the other 2 x-intercepts of f. Okay, they want the 2 x's of f. So this Casio calculator which I have here has the ability to find the x-intercepts for you without using any formulas or without using those different methods which you have. So this calculator here, which I'm having here, so what do? You go, you say mod there, then you say equation number 5, then after that you choose number 4 because that's a cubic there. So we put the values, then we have 1 there, we have -5, then our value of C is -8, then our value of D is 12, then we are done. So our x1 value, this is 8.2. So the first x value I'm getting here, it's so to make it look nice, so we can just say x-intercept, let y be equal to 0. So 0 is equal to x cubed, sorry. So we have x cubed there, minus 5x squared minus 8x plus 12 equal to 0. Then after that we use our calculator as I showed you. You say mod, then after that you go to equations, which is you press 5, then after that you put your equation there, then we're having the values now. So I'm having 3x intercepts here. So the first one, x is equal to 6, or x is equal to 1, or x is equal to -2. So of course this will be x plus 6, this will be x minus 1, this will be x plus 2, so this will be -6 here. So these are the factors, and this is how you find it. So just like that you have the answer, so you don't have to, there is no way you can make mistakes because you used your calculator. So it's mod equation, then you press your equation which are given, and after that you get the answers which you want. So this is a Casio fx99 minus 99178 plus 3. Okay, so that can be able to assist you as well in the process. Now sketch the graph of f, clearly indicating the turning points, intercept with the axis and stuff like that. So how can we plot our function, guys? So this is so straightforward to plot. Of course, this is something like this. Okay, so mine won't be that accurate, but yours, please make it a point that it's super accurate. Okay, so this is something like this. Let's do this. So it should be something like this. Okay, okay, sorry, should be something like this. Okay, here we go. That's not good enough. Yeah, then I go down, then yeah, something like this. Okay, then of course you put your turning point here, you put another turning point here, you put your x value here, another x. Of course this is 6 here is to 0, then of course this is what, this is 1 is to 0, then this is -2 is to 0 here. Then our turning point, we have the -1, which is here, this one, we have this one, so we'll put our -2 over 3 here is to 400 over 27. Then of course this one will be 4 is to -36, the other turning point. That would be what, -36. Then bingo, we are done with that one, just like that. So we were able to put our x-intercept, able to put, so we can also include our y-intercept here. So that will be what, 0 is to 12. Okay, that's the y-intercept. Y-intercept, we let every x value to be equal to 0. Then after that we are happy. If you are happy and you know, clap your hands. So definitely that was straightforward. That's how you plot your function. You must know your 2 stationary points or stationary coordinates and know your x-intercept. Then after that you live happily ever after. Determine the values of a and q, which means in the graph of g of x. So how do we determine that? So we should just be able to know our gradient first before we determine that. So of course our gradient of that line is always equal to y2 minus y1. Here we go, yes, minus y1 divided by x2 minus x1. So that would be what, 0 minus 16 divided by 6 minus 2. So that would be 16 divided by 4, that's 4. Then after that we have our gradient, of course. Then now we use our equation, y minus y1 is equal to x minus x1. Then what is y1 and x1? So those are the points 0 and 6. Okay, so that will be y minus 0 is equal to 4x minus 6. Okay, then after that we can have our equation y is equal to 4x minus 24. Then we have the equation. That's the equation of that line there which they have asked us there. So don't worry, I got you. Okay, then after that you can be able to calculate the value of a and the value of q. So then therefore a is equal to 4 and q is equal to negative 24. Okay, so these are the two final answers which are necessary or which were asked in this question. Now, determine whether the graph is concave up or concave down at point B. Concave, which means we must look for the second derivative. Okay, so the first derivative, we had the first derivative to be 3x squared minus 10x plus 8. So now we look for the second derivative of x. That will be 2 times 3, that's 6x minus 10. Then after that, now this is our second derivative. So since now we now know our second derivative, now we should now look at, is it concaving up or concaving down at point number B? And what is our point B? Our point B is when we have 2 is to negative 16. So the x value there, you can actually see that it's negative, it's positive 2, and the y value is negative 16. So that's already made our lives easy, because now we just have to substitute the value of the x value. So point B is 2 is to negative 16. So we can just substitute x is equal to 2 in f prime prime of x. Then of course now we can live happily ever after. So f prime prime of 2 will be equal to 6 times 2 minus 10. Then we get what? 6 times 2, that's 12, minus 2, that's 2. So we can definitely see that it concaves up, because it concaves up. Why? Because our f prime prime of x is greater than 0. So we can see that f prime prime of x is greater than 0. So definitely we can literally say with boldness and confidence that that will be a true answer if we say it otherwise. Now, for which values of x is f of x times f of x greater or equal to g of x? So you can solve this. When you solve this, you're gonna get these values which they say that these are the coordinates here. So when you solve that, these are the point of intersection of these two functions. So when you solve these two functions, you have these two values. So now we must now analyze them. Now we must be able to analyze these points here. We should be able to analyze what's really going on these three values. So our answer is just rotating on this fact that they are these intercept of these two functions. These are the point of intersection. So what I'm trying to say, that initially, since we know the reality, or we know that f of x is greater or equal to g of x, so in other words, we put our f of x here, which is x cubed, and then after that we have our 4x minus 24. Then after that we equate it to 0. So in other words, when you do this and you solve it and find the critical values, like you're solving for your inequalities, you're gonna get those values a, b, and c, because they are point of intersections there. So that will be easy for you guys if you do that. So in order for us to be able to answer that question, of course this will be easy, because we know the last value which we had on our graph was negative 36. So we can just literally say that 4x minus 24 is equal to negative 36. Then 4x is equal to what? Negative 36 plus 24. Negative 36 plus 24. That's negative 12. Okay. Then divide by 4. Divide by 4. Then our x value is equal to. Our x value is equal to negative 3. So now we know what's going on from that point. So then therefore, there we can literally see that, oh, okay, this is how everything is gonna go. This is gonna be between negative 3 less than x less than 2. Okay, less or equal to, then also, or when x is greater or equal to 6. That's why it's 6 marks. Okay, so we needed to know this value. So in order for us to know this value, negative 3, we had to solve this part here. then yes, then we have solved it, then we are happy. Now we are done with that 20 marks, guys. So 20 plus 11, that's already almost a distinction already. Okay, now let's look at the financial maths, the last section of today. Financial maths. I don't love financial maths because it's so hard, but let's try to make it simple for everyone. So financial maths is when we are talking about money, we are talking and we are building from what we have already learned in the past previous years, which is grade 10 to grade 11. We are introduced to the compound formula, straight line depreciation. We're introduced to those certain stuff. So let's answer and use the knowledge which we have already been taught in order for us to answer these questions which we have in this situation. Now, question 6. Okay, a school bought computers for 980,000. Okay, the value of computers depreciates annually at a rate of 9.2% per annum on the reducing balance method, which means we're gonna use the formula A is equal to P open bracket 1 minus N, because it has been it's undergoing reducing balance method and it is compounded annually. So we already know how to calculate that. Calculate the book value of the computer after 7 years. So what is important and the beauty of financial maths is when we exploit and when we understand the different terminology which we use. The moment you see compounded annually, which means it has been compounded per yearly, when you see quarterly, when you see semi-annually, when you see the value book, when you see the term book value, when you see reducing balance method, which means we use a specific formula. Let's go to the formula. Let's see if we have formulas for this financial maths. Yes, of course. Here are the formulas for financial maths. As you can see here, this is the one for straight line interest. Then this is for depreciation, or then this is for compound. When it's now going depreciation or reducing balance method. This one is when we have inflation, there's increase and stuff like this. So we actually have the formulas here. Even the formula for calculus, you can see it's here. Oh my word. And these are also the other two formulas which are important. The future annuity formula as well as the principal annuity formula. So let's dig into this question. This paper was so nice. Let's dig into this question and let's solve them. Let's solve these few questions which we have here. So calculate the book value. So how do we calculate the book value in this question? We calculate the book value by using our nice formula which says that this is what, 6.1. A is equal to P 1 minus I all to the power N. Then after that we just substitute the principal value is the amount which the school bought the laptops or the computers, which was 980,000. Then we save 1 minus, what was our interest rate? It was 9.2. So 9.2, we divide that by 100 because it's in percentage, or you just use your calculator before you write this. So 9.2 divided by 100, then you can see we have 0.092. So instead of writing like this, you can even just write 0.092. Then of course it is for 7 years. Then after that you use your calculator here. So it's going to be 980,000 open bracket 1 minus 0.092 all to the power 7. Then we have our answer to be 498,685,08 comma 82. Okay, because we are dealing with money, so you round off to the nearest cents. Okay, because we are dealing with money in this question. So that's how you solve it. It was not hard, it was straightforward and so easy for us to solve. Okay, now let's proceed to the next question which we have here. What is the question saying? Spokers invest 13,500 for a certain number of years. Oh my word, that's a lot of money. She earns interest at a rate of 8.2% per annum compounded annually. Oh, okay. The final value of the investment worth is that 20,000 and 20,28. How many years? This is where we're gonna use the future annuity formula, or you can use it. No, we don't have to use it because there are no payments which has been made. So we're gonna use the compounded inflation formula, which is 6.2. A is equal to P 1 plus I. Okay, so we're gonna use this formula here. So we are given that the future amount which she has to pay is that 20,000 there. So we write our 20,000 and 20,28 equal to the principal was 13,500. 1 plus what was the interest rate? It was 8.2%, so that would be 0.082 to the power of n. So we want to calculate the value of n, the number of years which all things happen. So of course the first thing, we divide both sides by 13,500, so that would be 20,000, and 20,28 divided by 13,500. Then I'm getting 1,482983704. Please don't round off before you arrive to your final answer. Then now we have 1 plus 0,082 to the power n. Of course this can be added together. Then we take the log of that. So the log of 1,082 multiplied by 1,48293,704 is equal to n. Okay, so we added this. So when we add this will be 1,082. Then after that we can take the log. So therefore n will be equal to what? Log of 1,082. Then that base there. Then I am getting exactly 5 years. 5,0000000. So our answer there is n equal to 5 years. Okay. Wow, this is grade 11 financial maths. It's so easy and straightforward. Let's do the last question. On 1st January 2017, Nelson deposited 3,500 into savings account. Wow, Nelson is so thoughtful. On 1 January 2020, which is after 3 years, he deposited another 5,700 into the same account. The interest rate for the first 2 years, starting from the 1st of January 2017, is 7% per annum, compounded quarterly, and the interest rate for the last 3 years is 8% per annum, compounded monthly. Calculate the amount on the savings. Oh my word, this is grade 11 financial maths. So this is when now we are looking at what we call the timeline. We're drawing the timeline that from this specific time it experienced this specific interest rate, and for this specific time it deposited another amount, it didn't withdraw. So we're just going to draw a timeline and solve this problem. So this is not easy, guys. So we want to know the amount in the savings after 5 years. So this is straightforward, guys, because it's already told that this one was compounded annual quarterly, another one was also compounded monthly. So another one we divide by 4 for the first 2 years, another one we divide by monthly, which is 12. So let's get down to it. So amount of saving will be equal to what? Of course, we know that our formula is A plus I. Sorry, A is equal to P 1 plus I to the power n. Okay, but now we are looking at the fact that it has a different timeline. So the first one, we say that they said that in 2017 it deposited 3,500. Then it was on a percentage of 0.07. Then we divide by 4 because it has been compounded quarterly. Then of course that was 8 payments there. Then we add another one when he we multiply by the interest again, which is 1 plus 0.08 divided by 12, which has been there since it has been quarterly monthly. So then we multiply there, then that will be 36 there. Okay, then we add another part now. That's the last payment which he made, which was 5,700, and it was 1 plus 0.08 divided by 12 because it has been compounded monthly, and it was for 24 payments. Okay, then after that we use our calculator to calculate the value of the savings. So that will be what? 3,500, 1 plus 0.07 divided by 4 all to the power of 8. Then we have to multiply by 1 plus 0.08 divided by 12 and all to the power of 36. Then we have to add 5700. 1 plus 0.08 divided by 12, all to the power of 24. Then I am getting my answer to be 11,793.19. Okay, so the amount of 7 will be 11,793.19 cents. Okay, then that's that. Thank you so much, guys, for tuning in. Share with friends, share with family that Yebo Tutor is back. Next week we'll be streaming, preparing for our trial exams. I hope you enjoyed the session. Please drop your comment if you want us to explain something more further, or if you have a specific topic. On the description of this video, there is a number you can just text so that you can be assisted, and you can also join our WhatsApp group. Thank you so much, Dango. Have a good night.